Okay, so what we had started looking at last couple of days was Pythagoras and tangent ratios, the grades and the pitches. We're kind of taking this information and we're just going to be adjusting it slightly. What we're primarily looking at today is we're looking at, you probably saw from like the first thing there, graphs. We're going to be using some graph stuff here. Specifically, we're going to be calculating lines on graphs, slopes of lines on graphs. It is exactly like what we've been doing the last little bit. The only thing we've added here is just the graph component of it. Now, one thing I'm kind of curious of on your guys' paper, so we're on page 24. Are you able to see like lines here?
Yeah.
You are?
I can.
Okay.
The second one is pretty hard to see.
Yeah, I wanted to try and make that a little bit darker, but I don't think I was quite able to succeed. What about on page, what about the next, oh no, this, yeah, what about on this page, the next one?
26?
Yeah. Or page 25, the big graph there. Is that one visible? Okay, okay, it's more, so it's more visible for you than, well, actually, let me just change my. Oh, still invisible for me, okay. That's, okay. So let's get up to this. So what we're specifically looking at here is we're looking at rates of change, and we're going to be looking at this a couple different ways. We're going to be looking at this concretely, pictorially, which is just pictures, and like symbolically. We're just trying to get an understanding of slope. Again, this is all still related back to the slope stuff. Rise over run. And ratios. It's all going back to that. And we're specifically looking at it in graphs. So if I give you a graph, there's a couple of things here. We use two letters to help coordinate a graph, what a graph is. Anyone know what those are? X and Y. So when we say X, we're talking about the X-axis. That's the stuff that's left and right. So the X-axis is this red line here. And the Y-axis, which goes up and down, is that blue line there. So this is just on page 24.
This is like the very beginning of like calculus or pre-calculus. Like
It involves it involves graphs. You need to be able to read and interpret graphs. Yeah, like those ones will mostly involve like, you know, you're looking at like x squareds and cubes and stuff like that. Yeah, yeah. For most of what we're doing is just going to be x, maybe 5x, maybe, you know, maybe 1 over 2x, but it's not, we're not going to have a lot of squared stuff in there. Yeah. Okay, so if we want to find the slope of a line in a graph, we can just pick any 2 points on that line. So we have this line here, right? And we see there's 4 points there. You can use that information to figure out 2 points on the line. So what we do is we just pick 2 points, and you're going to be looking at this stuff, and you're going to be like, well, what the heck is this? We're going to explain that. This 1 and this 2 means stuff. We'll get to that today. But we use a formula for this. So normally when we're calculating slope of, let's say, like a triangle or like a ramp, we've used m equals rise over run, right? That same concept kind of applies, but we're just expanding a little bit. So in this case, what we say is we're going to say that here, I'll use, yeah, we're just going to say that m is equal to, m is going to be equal to, it's still rise over run, but what we do is we use a special formula here to be able to find the slope. I'll fill this in just 1 second. Like this. Oh no, that's not that. Okay, here we go. So we say it's y2 minus y1 divided by x2 minus x1. Now, a lot of people look at this and they're like, what the heck? But this is still slope. It's still that m. M is also equal to rise over run, right? We still know it's rise over run. So what's this y2 and y1 stuff? Well, if you remember, we just said, what's y on the graph? This is stuff that goes up and down. So this is still your graphs. The x is what goes left and right. This is still your run. So it's still rise over run. We're still doing that. We just added some extra stuff to it. But at its part, at the core, it's still just rise divided by. And so remember, this is really important. We're going to be given lots of tools. You don't have to memorize these. You don't have to memorize most of these formulas. These will be given to you. The important part is understanding when the heck do I use it? I'm pretty confident that most people are going to be able to do this successfully. But the difficult part always tends to be, well, which thing am I going to use? Because now we're throwing a third thing at you. We use this if we want to find the slope of a line on a graph using 2 points. This is when we use this whole thing. And remember, this is still rise, and this is still run. And so if you're reading a book, how do we read the text? Do we go like bottom to the top, right to left? We go left to right. We read a graph the exact same way. We start at the left and we read it to the right. And so if that line, if you're noticing here, this example, what's happening to the line as we go from the left to the right? It's going up. This is going to mean that this line is positive. Right? It's increasing, it's elevating over time. Think about going on a long hike upwards. Like what happens as you go along the walk? You're going uphill. But if you're going on a walk and you're going downhill, the slope of that is negative. As you go from the left to the right, the line's going down. Oh, well, what we know then is the slope is negative. It's going down over time. You're losing elevation over time. And so we have a couple of key terms here. We're going to be referring to the sheet a couple times today because I'm not expecting you guys to be like, okay, we talked about all this. We've memorized. Let's go use it. We're going to refer to this a couple times today. But we have a couple key terms here. We have rate of change, independent variable, and dependent variable. So let's talk about these ones really quickly. So first off, rate of change. So rate of change is the rate at which, I'm going to make this smaller. One variable changes compared to another variable. That a little smaller. The rate at which one variable changes compared to another variable. We will talk about what that means. Now, I'm going to give you the definitions for independent and dependent, but then I'll give you an example that should hopefully make some more sense of it. It's going to be important. We're going to need to know what this is because you are eventually going to be making graphs, and one of these is the x-axis, one of these is the y-axis. Okay, so the independent variable is a variable. When we talk about a variable, we usually refer to numbers. It's a number whose values may be freely chosen. Which basically means in a hypothetical, that's just what they chose to do there. So it's a variable whose values may be freely chosen. And hopefully this makes more sense after I go through dependent here. So independent is a variable whose values may be freely chosen. Dependent is a variable whose values rely on the values of other variables. And again, like what does that mean? I will tell you the second you finish writing that down. Here you go. Make sure you leave just a little bit of space somewhere around there. Okay. So what the heck does this mean? Let's give you an example. Here we go. So one example might be, let's imagine you're on a road trip. So on a road trip, the distance you travel on it, like you're on a road trip, you're driving, that's dependent on, so the distance you travel is dependent on what? The speed and duration, or how long you drive. I'm just going to put that speed and how long you drive. So that's just an example here. Like one of these is dependent on the other one, if that makes sense. So the independent thing here is something that the values can be freely chosen. I can just be like, yeah, we drove 8 hours. We drove 6 hours. We drove 4 hours. But the amount of time that I'm traveling, the amount of distance I'm traveling is dependent on how long I traveled at a certain speed. If I'm going 100 kilometers an hour, I can say however long I'm going to drive basically, but it's dependent on the speed. It's dependent on how long that you drive. I hope that makes a little bit more sense with that. We'll look at a couple examples here, but it's looking at something that relies on another thing. And so I have one more thing to kind of add here. So when we have a dependent variable, we're going to put this, I'm literally going to put a big old Y. We put this on the Y-axis. When I have an independent variable, we put this on the X-axis. So it's going to be important for us to figure out which one is independent, which one is dependent. We'll have time to practice that. Like I said, we'll be referring to the sheet a couple times, but one of those goes on the X-axis, one of those goes on the Y-axis. We'll be using this for the next 2 months, basically. So we will be revisiting this constantly. And you know what? Sometimes you get it wrong. Your graph is probably still going to be okay for the most part. So if you don't get it right the first time, that's okay. You'll get practice with it. The really bigger thing I care about is that we're going to be able to do a graph properly, which we'll look at today. Yes. Okay. On your guys' page, is there a big gap here? On your, sorry? Oh, okay. So it's just if you choose any 2 points, like it's all.
Oh, yeah, yes, there's a whole.
Okay. That we are not writing anything down there. That was just me. I moved this graph too far down and it kind of messed some stuff up.
Oh.
Yeah. So there's no hidden meaning behind this. This is just I goofed up this graph a little bit. So let's look at this. Let's look at an example of this. So I'm going to use that same example, speed. So let's imagine that if you travel in a car at a constant speed of 50 kilometers an hour for a length of time, we know, after an hour, you go 50 kilometers. After 2 hours, you go 100. After 3 hours, you go 150 kilometers and so on and so on, right? That's not too hard to understand. The same thing, though, if I increase my speed, I go a further distance in 1 hour, a further distance in 2 hours, and again, so on and so forth. So basically, what we want to do is we're going to eventually calculate some of this stuff here. We're going to look at what the slope is, what the independent variable is, and what the dependent variable is. And we have 2 different lines here. The only one I'm going to care about right now is we're just going to look at, make this a little bit thinner. We're just going to look at this 50 kilometer an hour one. We'll just do one of them. So just make sure you put a little box around like this 50 kilometer one here, because that's the only one we're going to look at. So let's get into this. So if we're looking at this line, what's the slope of our 50 kilometers an hour thing here.
50.
Yeah, 50 over run, right? 50 over 1, right? You go up 50 for every 1 hour that's happening here, right? I go 50 kilometers after an hour of driving at 50 kilometers an hour. That's not too hard to understand. So what I know then in this case is that my slope is just going to be 50 over 1. I meant to make this red. There we go. So my question for you is, which one of these two, so what's this graph measure? It's measuring two things. Well, technically three. It's looking at your distance and your time. And between those two, we get the speed, right? If I if I go 200 kilometers in 2 hours, how far was I driving? Or how fast was I driving? 100 kilometers an hour, right? My speed is determined by how far I travel over a certain time. So in this case, these are my two variables. One of these is dependent and one of these is independent. So I want to go over what's the independent thing first. And if you remember, independent variable is a variable whose value may be chosen freely. Well, so that's kind of a cheat code here is I know the independent variable needs to be on the x-axis, which is this thing here, this line right here, right? I'm going to erase this red, but this is the x-axis right here, this red line. So I know that this is my independent variable. In fact, I'm just going to move this down here. So what's my independent variable? It's time. Specifically in hours. There's that little h there. I can just, this is all make-believe. I can be like, how far does the car go if it goes 12 hours? How far does it go if it drives for 100 hours? It's just like a make-believe. But the distance I travel, which is my y-axis here, right? This is my y-axis. Here, I'll zoom out a little bit. So y is when we're going up and down. That one is my dependent variable. So the distance I travel is dependent on how long I'm driving at this speed, right? That's why that's a dependent one. And again, a good cheat code is, well, the independent is always X and the dependent is always Y. So let's take a step back here. Let's review some of the basic stuff. So I'm just going to go to this next page here. And are you guys, again, are these lines showing up for you guys?
Yeah.
Okay, good. So if I'm looking at this question, first off, the question's asking us, we want to consider each of these graphs. There's 3 of them. Are the slopes positive or negative? And then it wants us to calculate each slope. So this is asking us 2 questions. 1, are the slopes positive or negative? And 2, what is the slope? So first off, is this one positive or negative? Positive. How come?
Going left to right. That's going up.
Yeah, it's going up as we go left to right. So it's going to be a positive slope. You bet. And then I want to actually calculate what the slope is. So if I want to calculate what the slope is, so first off, what do I have here? I have a line. So I know I need to be able to use that. What do I do? How do I calculate the slope of a line? Equals rise over run. Kind of. Specifically, when we have a line, though, we're going to use this thing here, y2 minus y1 and x2 minus x1. What do those mean? Let's go into those. So first off, I'm just going to put my blank formula here. m equals y2 minus y1 divided by x2 minus 2, 1, 2, 1. Make this smaller. Okay. So if I have a line, I'm trying to find the slope of it, I immediately need 2 points. And I will show you why right after this. You need to have 2 of them. You can't just pick one. It might not give you the correct answer here. So first off here, I need 2 points on this line. Oh, hello. So I need 2 points on this line, so I need to be able to calculate it. So first off, let's go find 2 points. So what I'm going to do is I'm going to look down on here, and you can see there's a dot here. What we want to find the coordinates of this point. So we always read it as, we always do x and y. It's kind of like a treasure map. You're reading it like coordinates. So right now, if I go to this dot, if I want to see where it is on the x-axis, I'm just going to look directly underneath it. I'm drawing this imaginary line. You're not always going to have to do that. You'll eventually just be able to look at it. But where is this on my x-axis? It's on 4. So this right here is 4. And then on my y-axis, which is how tall it is, it's 3. So a really common mistake that people are going to make here is they'll be, oh, this point's 3, 4. It's not 3, 4. You have to do x and then y. It's always x first, then y. Just like how it is in the alphabet. What comes first? X instead of y. So we always go x, then y. It's 4 and 3. So I know on a graph, I know exactly where this point is. It's 4 and 3. So I have 1 point, but now I need a second point. First off, is there any other dots that it gives me? No. So to find a second point, what do I have to do? I can just kind of pick one. I can be like, well, what happens if x is at 1 here? Okay, well, it's like that. That doesn't quite give me a nice number. I could guess, but that's not quite what it is. A really good like cheat code here that's going to work for most things is, well, this is a point. What's the x here?
0.
What's the y here?
0.
So it's 0, 0. That is a point. That works. It's on the line. So now all of a sudden I have 2 points. Now I can use this information to find my slope. And the reason you need 2 points is, what's the rise of this? 0, 0, 0. Rise of 0, rise of 0. What's the rise of this point?
3, 4. 4, 3.
Not 3 or 4, because you have rise first and then run. So they have 2 different ones. So what we're looking, so you can't just pick one, they're different. But if it's a straight line, it's a perfect straight line. What I can do is I can just figure out, well, how much does the line rise up as it goes to this point here? So that's why we pick 2, because then we're going to get that nice consistent rise and run. Now, the only other thing here is, I'm just going to erase this, make this a little bit neater. We have these y2s and these y1s and these x2 and these x1s. What the heck are those? Well, this refers to where it is on the point. We have 2 x's that we've picked here. On our graph, we have 2 x's and we have 2 y's. So as we read a graph, how do we read it?
Graph 4, 3.
Oh, so well, how do we read a graph? Just like a book.
Left to right.
Left to right. We read it from left to right. So if my graph starts right here, as I go from left to right, I immediately find one. Right? This is the first point I found. So this is my x1. This is my y1. If that makes sense. This is the first x I see. This is the first y I see. So let's go into that right now. But so first, just as a quick reminder, so these are going to be, this point right here is this is my x1 and y1. You don't need to write this down every time. I'm just doing it for this first time, just to give us a bit of a reminder. And then this is my x2 and my y2. This point over here. So again, this is another common error is, okay, maybe you'll have your coordinate points here, right? But you'll be like, oh, this is my X one here. No, it's not, because remember, this is the second point I see. As I read this line from left to right, this is the second one. That's a really common mistake people make. They'll do everything else right, but they'll just get that part a little bit mixed up. So it's really important we get that correct. So looking at my graph, zoom out a little bit. So looking at my graph, what's my Y2? What's my second Y I see? Well, isn't it 4 and X? So it's going to be 3. So it's going to be 3. And then what's my Y1? 0. And then that's just divided by my X2, which is 4. This is the second X I see, right? And then my first one was just 0. Okay, well, this is not hard math now. 3 minus 0 is 3. 4 minus 0 is 4. So what's my slope? 3/4. For every 3 it goes up, it's going to go 4 across. I have evidence of this right here. So yeah, this would just be my final slope then. And not only that, you see how it's positive, right? It's a positive slope. So that's when we, yeah. You're looking at. So this one would end up having a negative fraction. So that's an easy way to check that. Did I do the Y2, the X2, the Y1, the X1 right? Did I put those right? Well, yes, because if you would have done this the other way, you would have had a negative slope here. It would have been 0 minus 3. The second one will be positive, right? The second one will be a positive slope as well. Yeah. So we're done this first one. We've answered both these things. We figured out the slope and we know whether it's positive or negative. So let's go to this next one. So first off, you already said it. It is a positive slope because as we read it from left to right, it's going up. Yes, that's absolutely right. Yeah. At zero, it's really high on like yeah. So first off, this is a positive slope because we already established as we read it from left to right, it goes up. So what I'm going to do for this next one here is I'm just going to write our steps really quickly. So step 1, what we did was we need to how did I say that yesterday? I'm going to scroll up. How did I type that yesterday? I want to keep that language consistent. So I'll come right back down to that. Yeah, okay. I literally just said write the formula. Okay. Come on. So step 1 is just write the formula. So I'm using a graph to find a slope. What's my formula I have to use then? Yeah, m equals. I'm just going to do this. I'm just going to do that, just to keep it. These are supposed to be little, but just to keep it neat. Okay, so I'm writing my formula. My next step here, what I'm going to do is I'm going to find step 2. I'm going to find 2 points on the graph. I'm just going to put find 2 points. So I'm going to find 2 points. So we're going to go do that now. So I'm going to need to zoom in here in just a second. So I know it's pretty small for your guys's graphs. So I'm just going to zoom in a lot here. So we have our graph here. So first off, how can I find what the coordinates of this point are? We always do X and Y. We always do X and Y, but so let's do X first. Is X this line to the left or the one on the bottom? It's the one on the bottom, right? This is my X axis. It's usually labeled for you. You can see a little X there. So in this case, I know it's kind of hard to see.
3.
Yeah, probably a 3. Yeah, yes, it is 3. Yeah, you guys have lines, I guess, so you can see better than I can. So first off, this is going to be a 3. And then what's the Y? 5. So what was my mistake here? First off, I just made an error. Right. I put the Y first. No. Just like the alphabet, X goes first. So it's not 5, 3. The coordinate of this point is 3, 5. And is this the first point or the second point that we see on here? First. So I'm just going to put a little 1 here. You're not always going to have to do this, but again, this is just a nice thing to keep us organized at first. So this is my first point. So this is X1, this is Y1. And then we're going to go to this next point here. What's the coordinates of this little dot here? 6 and 10. Yeah, you're right. So yeah, this is my y-axis here, and you're right. So it's 10 is the y, 6 is the x.
That would be X2 and Y.
And this would be my second one, I see. And again, the explanation is, how come I know that's my second one?
2 dots.
Well, there's 2 dots, but how come I know that's the second one, not the first one? Remember, as we read a line, we read it from left to right. This is the first point I see. This is my first one. And this is the second point I see. So we always read it just like the book, left to right, left to right. Under the 10, that's a 2. Sorry, that's a 2. Okay, so step 2 is find 2 points. We've done that. And so all we have to do now for step 3 is we substitute and solve. We have our blank formula. We have 2 points now. We just input that information into that formula we have. So M is going to be equal to, what's my second Y? Is it 10 or is it 5?
Okay.
It's 10. It's the second point I see. So it's 10 minus 5. Oops. Because remember, it's our rise. This, M equals rise over run. Well, we have this same thing. This means the same thing. We're looking at the changes in height. So we're only looking at the stuff on this y-axis there. And so then it's going to be all divided by x2 minus x1. What's my x2? It is 6 minus 3. Like, okay, that's not hard math. 10 minus 5 is just 5. 6 minus 3 is just 3. Oops, let me just actually erase this line. And a quick check, did I do it right? For every 5 it goes up. Okay, here it's going up, this point's going up 5. I'm gonna go up 5. I'm gonna go across 3. Yep, there's one of my points I use. So I know it's correct. I can see it's a positive slope. I don't have a negative in my M equals something, so we're good to go. Okay. So everyone have that down? So this final question here, what makes this different or more difficult? It's a negative slope. The line goes down as we go from left to right. So that's what's making this a little bit more difficult. So now we're throwing in negative numbers. We still solve it the same way, but everyone gets a little wonky when we get to negative numbers. You have a wonderful computer. This is 1,000 times stronger than what took mankind to the moon. So we can use this if we need to. That's fine. If you're not too great at negative numbers, that's okay. We have tools to use. So let's go into this. I'm not going to rewrite these steps anymore. We're just going to hammer it out. I have two lines. Sorry, I have 2 points. I have a line. I'm trying to find the slope of it. What tool do I need to use? Yeah, m equals y2 minus y1. And that's all divided by x2 minus x1. Oops. Again, it's important to know how to solve it, but also why we're using this. The reason we are using this one over many the other things we've learned is because we are using 2 points on a line to find a slope. We're involving graphs in this, so we can't just use our normal rise over run. Cool. So I've written my formula. Done. My next step is I need to find 2 points. Yeah. Is there 2 points on here?
Yeah.
Perfect. If I don't have 2 points, I can always use a cheat code. I can usually use 0, 0, or I can just pick any point on a line. Cool. So I now have 2 points on here. Let's quickly label them. I'm gonna just like a book, I'm gonna read this graph from left to right. I'm gonna zoom in a little bit. This is the first point I see. What's the x and y of this?
0 and 10.
0. It's 0 on this x-axis right here. And it's all the way up at 10 at this y-axis. So it's 0 and 10. And is this the first or second point I see?
First.
This is the first point. So these are my ones. I know it's a little messy. I apologize. When I zoom in this much, I can't actually make the text that small. And then what's my second point here?
9.
Yeah, it's kind of hard to see. You are correct. It is 9. So this one would be, so my x coordinate here is a 9, and my y coordinate here
5.
is a 5. So this one's 9 and 5. And you can always take a ruler, like your pen or something, to line it up as well. You don't always need to draw these lines if you have a good eye. And sometimes we make mistakes. Sometimes we miscount and stuff. Those things happen. That's okay. So cool. My step 2 is done. I have 2 points. Is this my first or my is this my x2 and y2 or my x1 and x1?
X2, 1.
Yeah, this is the second point I see as I go through here. You do not need to label these. If you got that down, that's okay. I'm just doing that to show it. Okay. So I have my blank formula. I have my 2 points. My final step is I'm just going to substitute that stuff in. I'm going to solve the equation. So m is equal to, what's my y2? We're gonna pick on Tamara. You're not Tamara?
Oh, sorry.
So how do we get 5? So first off, when we're talking about, we have those. So these are the 4 points we have, right? We have x2, x1, x2. We have y1 and we have y2. So we always label our points in the same way, which is the x goes first, then the y. This is why this point over here is 0 and 10 instead of 10 and 0, because it's 0 on the x-axis first, if that makes sense. So that's how I know which one's my x and which one's my y. As to, well, which one's my 1 and which one's my 2? As you read the graph, you read it like a book. You read it from the left to the right. So I start with my graph on the left, and I'm finding the first point I see, which is this one. So these are my ones, which would mean this, the 0 would be x1. The 10 would be, which one of these?
Y2.
Sorry?
Y2.
This one would be y1, because it's the y point, and it's the first point I see. If that makes sense.
No, it's
We'll get it, remember, this is actually usually the trickiest part of this. We can all do like 10 times 5. That's not hard math. The hard part here is properly labeling the stuff and identifying. And so then this next point here, this is the second point I see. So these are my 2's. And this is my x, my y. So I have my 2 points. I'm just going to substitute it in. So m is going to be equal to my y2 is 5. My y1 is 10. And then what's my x2? So my second x I see here is a 9. And that's all take away 0. Remember, this is the part where it's most likely we're going to make our mistake there. It's just where we just mislabeled it wrong, or oops, we put this in this here instead of what's supposed to be there. So now it's not that hard of math. It's just 5 minus 10. Which again, if you're not too great at negatives, that is okay. We have a really powerful computer. You can just do that. 5 minus 10, -5. So it's a -5. And we know what 9 minus 0 is. It's 9. Now, something I really want to make sure we're paying close attention to is, okay, I put -5 here. Cool. Which makes sense. We know it's a negative slope. We established that at the very start. It goes down as we go from left to right. But how we actually interpret this graph is the slope is negative. So I move that negative over here, and then it's just 5/9. These mean the exact same thing. This is just how they write it like properly. Right now, you will not encounter issues if you stick with this thing right here. You will not encounter issues if you do that. Eventually, though, you will encounter an issue, more specifically towards later in this course, next course, if we don't do this. So I recommend let's just do this right off the bat. It's a negative slope, so it's -5. These being the same thing. It's not going to matter too much right now. It will come back to bite us a little bit if we don't fully get that down, though. Okay, everyone has that down? So what I'm going to get you guys to do here is I'm going to get you to go down to question 29, or sorry, page 29. There's going to be 2 questions here that I'm going to want you guys to try out. Just try it out. If you're not sure, you're not confident, feel free to do it on loosely. Feel free to do it on your board. The one thing I want to mention, though, is question 2. What makes this harder? Yeah, it's just straight lines. So normally we're used to some steepness. This is either straight up and down or straight left and right. So you still solve it the same way. It's going to play some mind tricks on you, but just try it out. Just try it out as best you can. We'll go over quickly. So you have 2 questions here. I'm going to give you guys like 5 to 7 minutes or so to just try it out. If you're not sure, sorry, 1 and 2. Try out 1 and 2. And I will give you guys a couple minutes for that. And like I said, the whole point of this is we're just trying it out. If you're not sure, just try.
So will there be 2 different equations?
Oh, sorry, actually, I just want to pause this real quick. Yes. Before, not a lot. Now, usually once or twice a week.
Yeah, because I have someone asking if you could get the CT posted.
I probably could. Yeah, I could probably transport that. Yeah. Let's go into this stuff here. Just really quickly. This first one, it seems like we all got it, so I'm just going to power through it. But basically, what we're asking here is we're asking what's the steepness between these two lines. I have line 1 and I have line 2. So first off, before I even go to the math, which one's steeper? Line 2. It's line 2, right? Because they both start from the same place. Like it's literally, we look at it and we know it's steeper, right? It changes in elevation more. Like which hike would you rather do? Which hike is harder? This one's harder, right? Because you're having to go up a lot more than this one. Like think about it that way. It's like when it talks about which one's steeper, which is the hike that your legs will hurt the most at? Definitely the higher one. Because you're going higher over the same amount of distance. If I look at this 5 here, as an example, well, line 2 is higher up in the air, right? I've gone the same distance, I've traveled the same length, the same run, but I've gone up higher elevation. So that's why that one's steeper. So one thing you guys had found out though is you ultimately found out that line 2, I won't do all the work, but line 2's slope was 6/4 L2. I think that was, it was 6/4, which you can simplify into 3/2. These mean the same thing.
Would we get marks off if we did simplify it?
I will usually unless I specifically say simplify it as much as you can. Your calculator will do that for you, by the way. If you just put 6 and 4 in and you press change, it will simplify it. And then line 1's, I don't actually remember, what was line 1's? 3/5. So these are the slopes of those two lines. Cool. And we just explained why one is steeper. It goes up higher when you travel the same amount of run. When I go 5, let's imagine this is 5 kilometers. Line 2 has just gone up further in the air, which means it is steeper. Again, when you think about steepness, is just think about which one's going to hurt my legs the most when I climb up that mountain. Sorry? Work? They should be the same amount of steps. Or you mean line 1? Oh, those are just the answers. Yeah, I didn't go through the full process. Just the answers. Yeah. Now, where I will go through the full process, though, is these ones. So first off, everyone's noticed that these are weird. And we've already identified why these are weird. They're straight lines. Specifically, they don't just go up. They don't have rise and run. They just either have rise or they have run. So let's quickly run over those. So this one over here is line 1. I'm going to do line 1 first really quickly. So same thing, M equals, I'm going to use the text feature here. Use my text feature, make this a little bit neater. So I'm doing line 1. So M equals, it's rise of y2 minus y1 all over x2 minus x1. We just already proved that all of us can do this. The only thing that's weird here is there's going to be zeros here. So my second point here is, what is this? This is 9 or not 90, 96. Oh, yes.
I don't know why one and x1 is like one is closest to 0.
Not in most times, yes. There will be some weird situations where no. So like what I always recommend is literally just, oh, what did I break? I always recommend literally just follow the line, like left to right, and then just identify this is the first point I see here. and then just keep going and like, oh, this is the second point I see. So these are my ones and these are my twos. I recommend doing it that way because like technically what you're saying probably could work, but there will be some rare situations where that will not be true. So it's important to understand necessarily like why this one's one and why this one's two. And it's just because it's the first point you see. Because sometimes like you might have to make a point like over here. Sometimes you might have a negative point, for example, which is something we'll get into later. Does that help? So I'm just going to go into this one here. I'm just going to label my points. I have 9 and 6, and this other one on line 1 is 2 and 6. So I'm just going to substitute that in. So my y2 here is going to be 6 minus my y1, which is also 6. Oop. And that's all going to be divided by x2, which is 9, minus x1, which is 2. And that's going to give me 0/7. Now, what this actually means. So first off, I'm talking about, make this a little bit thicker. Ooh, too thick. I'm talking about this red line here, right? So this makes sense. This has a slope of 0/7. It's not going up, right? This is still your rise. This is still your rise. It's stuff that goes up and down. It's not changing at all in elevation. It's just a nice, smooth, flat line. So it doesn't go up at all, but it's always going to go further and further left and right. It has an infinite run, technically. Like if I was to ask you, well, what about if x was at 13 or 10? It'd still be over here. Are you just stretching or do you have a question?
Oh, no, okay.
And so you can probably guess what's going to happen for the other one. I'll use blue for this. So you can probably guess what's going to happen for line 2 here. That's not blue. So line 2, I just do it the same way. y2 minus y1. I shouldn't have the big 2s and 1s there. I'm just doing it to be lazy right now, just to kind of get to the main point. Oh gosh, not that. What were my 2 points here? This is 4 and 9. And then what was this point? 4 and 2. Perfect. Cool. So I'm just going to substitute that in really quickly. My y2 is 9 minus 2. And that's all divided by x2 minus x1, which is 4 minus 4. Which is going to give me 7/0. For here? Yeah, you always want to have the y2 and the y1 there, yeah. Like you couldn't have 2 minus 9, for example. Well, these are kind of weird. In this specific case, you actually probably could get away with it, but I'll talk about that. But so, same thing. Okay, this one goes up 7 for every 0 it runs. And we see that, right? It just goes up and down. It doesn't move to the left or right here. It's just going up and down. Now, you're going to need your calculator here. I want to put those fractions in our calculator. So go to the first one here. Just put 0/7. So just use your fraction button. That's the AP. This is technically 0 divided by 7, right? So 0/7. What's going to happen if I press enter here? It's 0. 0 divided by anything is always going to be 0. So what this actually means is I have a slope of 0. Well, that's kind of weird. But when we say we have a slope of 0, it just basically means that it doesn't go up or down ever at all. The difference here though is when I go to this one, if I put 7 over 0 now, I'm using the other line slope. What's going to happen? Breaks the calculator. You can't divide by 0. The second you divide by 0, it breaks your calculator. So that's basically meaning that the line's going up forever. It only just goes up and down. It has same thing. It doesn't have a slope because it's not running. Your calculator just processes a difference, but we're very rarely going to see these, but it's just kind of nice to know. You calculate it the exact same way, but technically, if you simplify this, you get 0. If you simplify this, well, you can't. It just breaks. So why don't we go for our break here? When we come back, we'll actually learn about drawing some graphs. You'd get that right, actually. Because technically, when you simplify it, it is 0. So we'll go for our 15-minute break here. We'll come back at 2. Oh, you're good. Did you flip the switch back? Oh, if it's not charging your Chrome book, try that report. No, you're good. You're good. Did you try to report on? Yeah, it's not. What's that's pretty low. Oh, maybe that one. That's the first one. So we're just on page 27. We're looking at graphs. I just want you to cross out this 12.25. Just put $15 an hour here. Let's not deal with decimals right now. So cross that out, put in 15, make our life easier. So we have an electrician assistant. They earn $15 an hour. First off, you'll earn way more than that. But for the first question here is asking us, what's the dependent variable? Before I even go into that, what's the two variables I have? What's the two things that I'm measuring in this above sentence here?
This variable,
well, but so like when I say variable, like what is that?
X and Y.
Well, X and Y, but so like what would I put on X and Y in this case? And I'm just looking at just everything in this sentence here, just that first sentence. There's two variables in here.
An hour.
So you got them both. So I have money. You don't have to write this down. In fact, I recommend don't do it. Money and time. Those are my two variables here. So when I'm talking about variables, those are the two variables I'm going to measure with this. A graph is always looking at two things. We're measuring two things, and then the slope, and then the line you get from that is a third thing, if that makes sense. So we have two variables, we can make a graph out of it. So what is the dependent variable between these two things?
They would be X.
So are you saying money would be the dependent variable? Well, dependent in this case would be money. How much money I make depends on how much I work, right? So what's the dependent variable? It's going to be money. Everyone's favorite thing, money. So first off, what's the dependent variable? Money. I'm going to put money equals dependent, actually, just to clarify that one. So the question A is asking us two things. First off, what's the dependent variable? It's money. How much money I make depends on how much time I work. It depends on my salary, right? So now it wants me to write an equation. Now, most people see this. They see this, write an equation, and there's like, oh, let's think about it logically. How much money you make. Money is just equal to how much, like your salary, your wage, times the hours worked, right? Again, thinking about it logically, hey, how much money do you make? Well, it depends on my salary. It depends how much I want to work. If I have a job that pays me more money per hour and I work a whole bunch of hours, I'm going to make a crap ton of money. So that doesn't need to be super complicated. You can think about this logically most of the time. How much money I make is it's just how much I work and how much I get paid per hour. Cool. So now I want to graph this equation. So don't write this down. Don't write this down. I'm just using this as a reference. Do not write this down. When we have graphs, there's a couple of general rules we want to have. One of the rules is we want to try and have it be neat. Again, you do not write that down, but we want to have it be neat. We want to try and use over half the space. So you want to try and use at least half of the space. And what the heck I mean by that is I don't want a graph that's like that. You know, 1, 2, 3, 4, 5. This is not a good graph, right? It is too small. You want to have a graph that is a heck of a lot bigger than that. Maybe it's using up something like this. This is a much better graph. We can get better information from that, right? You have the space there, use it. So that's what I mean by that. You want to try and use over half the space. And the final, I think this is the final rule. Oh no, just we want to label it, which we'll talk about. And then we also want to, how do I want to say this? Keep it proportional, which will make sense in a second. So I'm just putting this here as like just some rules to kind of like follow. Everyone is going to eventually. What's going on? There we go. Everyone at some point, we're all going to be making lots of graphs. Like some of our units is like it's all we do is graphs. Everyone's going to have different looking graphs, and that is okay. Just because your graph is going to look a little different than mine, or mine looks a little bit different than yours, doesn't mean one is better than the other. As long as it's following these like guidelines here, you're doing okay. So when it wants me to graph this equation, there's a couple things I need. The first thing is I have an X and a Y axis here. I'm just going to quickly put that in. I know this is my X. I know this is my Y. I'm going to quickly put that in. In fact, I'm going to make this blue because we don't really need this. Blue. Okay. So I have my X, I have my Y. I need to put something here. Now, I've already established what my dependent variable is. Now, if we remember, I'm just going to scroll up for a second. My dependent and independent variables always go certain places. My dependent variable always goes on that y-axis. My independent always goes on that x-axis. So independent is x, dependent is y. I know what my dependent value is, money. So which one of these does it go to? The y, yeah. Money earned, dollars. I'm labeling my graph right now. It's what's happening. This is what I'm doing. So when I put money earned dollars, that's this whole line. Which means, so if I have money, what's going to be on the bottom here? What are my two variables again? Look at question A. Money and time. How do we usually like measure how long we work in a day? Hours. Yeah, I work 8 hours a day, right? So time. Hours. And time is my independent variable because I can just be like, yeah, how much money would I make if I worked 100 hours? Cool. How many lines do you guys have there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You guys can see those like little lines here, right? On yours?
Yeah.
Cool. Cool. Okay. So you can see them. That's great. So what do I mean by this keep it proportional thing? What the heck does that mean? I'll load that back up, Tamara. I'll load, like you're looking at that sheet from before. Oh. Okay.
Keep it like even.
Kinda. I can't just be like, don't write this down. I can't just be like, yeah, $15. Here's 100. Here's 115. That doesn't work. It has to go up at the right pace, right? And you guys see how you have 10 different lines there? So wouldn't it make sense if I just go up by like, let's just say $15 for every line you have here. So maybe I'm like 15, 30. I'm just going up by 15s, right? You could go up by 10, 20, 30, 40, 50. You could do that too. This is when I said that everyone's graph's gonna be a little bit different. 45, 60. So all I'm doing here is I'm just putting in just some nice, easy values that I think are going to work good with the graph. The reason I'm picking $15 here is, any guesses? Why am I going up by 15s? Yeah, because he's making $15 an hour. It's going to make it really easy to put what I want there. You could go up by 10, 20, 30, 40. That would still work. But so that's what I mean by keep it proportional and keep it neat, is I'm putting a little bit of thought into the graph before I go and do it. It's a hard skill to do. Everyone's going to have a graph that looks different when you go off and do this by yourself, and that is okay, as long as it makes sense and it's readable. 120, and I've used up most of my space at this point. I think that's probably fine. I've used over half of it. I can leave it at that. I can always add on to it later. Now, what should I probably go up by time? Yeah, 1 hour, 2 hour, 3 hour, 4 hour. That makes kind of sense, right? You guys have what, like, looks like 10 there as well. What do I go up by that? Yeah, 1, 2, 3, 4, 5, 6, and I'll go up to like 8 hours, because why not? Again, I've used most of my space there. And then this little dot here, what does that technically mean here? 0. I'm just going to put 0 there to reference that. You don't have to. You don't have to do that. I like doing it. You don't have to. Cool. So I've labeled my graph. Check. I've used over half the space. I've kept it proportional. I've kept it as neat as I can. Keep in mind, I'm on a mouse on a computer. It's not as nice as on pen and paper. Cool. So I probably am going to have a good graph now. Now all I need to do is start graphing my points. I don't have my points. So I need to generate them. Or I can just kind of, think about this logically. If I make $15 an hour, after 1 hour, how much am I going to make? 15. That's not that hard. After 2 hours, I'm going to make 30. After 3 hours, I'm going to make 45. Now, what I recommend you guys do is, just put down a couple points. What about after 8 hours? How much would that be? 120. 8 times 15, 120. What I recommend you guys do is do a point at the very, very start of it. Do a point at the very, very start. Do a point near the end. Just take a ruler, take a pen, take something, draw a nice straight line. Don't just try and freehand it, because your graph is going to end up looking like mine, which won't be good. Like, you can literally use another pen as a ruler. I have rulers if you need to. Just draw a nice straight-ish line as best you can. It should go through all your points somewhat. You're not going to have a perfect graph, right? You're not using a computer program to make this. You're using your hands. If you're off by a centimeter, it might look weird, but that's okay. You're going to get a graph that eventually should look something like that. I'd put a couple points in, yeah. Yeah. So first off, have I graphed it? Am I done? Looks like it, yeah. I think so. Like, I have points in, I have labeled everything, I put the correct values in. It meets these 4 like rules up here. Yep, I'm done. I've graphed it. Good enough. Cool. Is there any questions at all about like graphing, like drawing a graph? Here, none? Awesome. So now what it wants to know is, what is the slope of the graph and what does it represent? So the slope of the graph, oh, I'm using a graph, I'm trying to find a slope. You know, we would end up using this we would end up using this m equals y2 minus y1 divided by x2 minus x1. I'm not going to go through that whole thing. I'm pretty confident everyone here can now do that. I'm just going to tell you what it is, which should make sense. How high up is this going? What was the run? 15 and 1. M equals rise over run. Well, what's my rise? 15. What's my run? one. I know, and this is normally a bad thing to do, but like I know it's going to go up by this. I drew it to go up for 15 every one it goes. So my slope here is 15 over 1. So that's what the slope is. But what does it represent? And this is where it's important to look at the context of the graph. When I go up 15, I'm going up $15. Basically, the slope of this graph represents that how much money I earn over time is what this shows. I will know that if I work 5 hours, well, I'm going to make $75. If I work 8 hours, I'm going to make $120. That's what it's showing. So what does this line represent? What does the slope represent? It represents how much money you make per hour. I'll make that bigger.
Oh, okay, just start representing how much money you earn. Or you have to put per hour.
I would put per hour because how much money you earn is only this. So this line is, so remember, graphs measure 3 things. We take 2 variables, how much money you made, how long you worked, and we combine those 2 to get a 3rd thing, which is how much money you made over, or your salary. Okay. So let's go into question D here. How much does he earn in 5 hours? Now there's 2 ways I could figure this out. I'm only going to solve this one way. I'll solve the next question the other way. First off, how much does he earn in 5 hours?
75.
How did you get that number?
15 times 5.
Yeah, you make $50 an hour, you work 5 hours. 15 times 5, right? Not that hard. You can also go to your graph, literally take 5, figure out where that is in the point, and oh, it's $75, right? You can do it that way too. So one way is usually just common sense. How much did he earn in 5 hours? He made $75. The other way is not as common sense, but it comes in handy. So for question E, first off, I want you to cross this out because we changed our 12.25 to 15. So I want you to cross out that 183.75. And I want you just to put $187.50 there. So first off, I can't use my graph. I didn't graph it up to 187. And not only that, it's kind of hard to like figure out where it's even hard to figure out, well, where's 87? It's somewhere here, but we can't get really precise on it, right? So we can't really use the graph thing. We can't use the common sense as much of this. It's a little bit of a harder number. The second you throw decimals in, usually our brains turn to mush a little bit. We could probably, we probably have an understanding of, well, couldn't I just divide this by my salary to get it? You're right, you could. I want to go back to that algebra thing here, because sometimes this will come in handy. But first off, how could you figure out how much this is? You could just divide this by his salary, right? Another way to think about it is, remember this stuff up here? When I said, let's write an equation up here. What was our equation? It was money equals your wage times your hours worked. I'm just going to quickly put that in. Your money earned is equal to your salary times the time. And again, you could use this with just like common sense and stuff and like a calculator, like that'd be fine too. But sometimes this algebra does come in handy. Do I know how much money he earned? $187.50. So all I'm doing is now I'm inputting what I know. Write my formula, substitute, solve. That's half the course. Write the formula, substitute the stuff, solve it. Do I know his salary? Don't I?
Oh, 15 an hour.
He makes $15 an hour. So his salary is 15. Do I know how much time he worked? No, that's what I'm trying to find out. So I'm just going to leave that there. I'm just going to leave T there. T for time. Right? Does that make sense? I put it a T there because we're mathematicians, we're lazy. T is equal to time. So just like algebra, well, I want to get this T thing by itself. I want it to tell me what the salary is, right? Your time is equal to blank. I need to get rid of something that's attached to it. What's attached to this T? Well, the times. But the 15 times, right? It's 15 times time. So I got to do the opposite of this. So what's the opposite of times in? Dividing. And so what's the opposite of times in by 15? Divide by 15. I'm going to divide both sides by 15. What's going to happen on, so I'm looking at this right side here. These are going to cancel each other out, right? Sorry, this is a divide. I know the dots are a little hard to see. This is a divide there. So those two 15s cancel each other out. What am I left with on the right side? Just the T. Have I done it? Have I isolated my thing? Do I have it by itself? Yes, I do. Which means whatever's on this other side here has to be the answer. How do I find out that? I just follow exactly what it's telling me. $187.50 divided by 15. 187.50 divided by 15. 12 and a half hours, right? 12.5 hours, 12 and a half hours. Again, this is just that algebra thing. Common sense would dictate, well, you just divide it by his salary. You'll figure out how long he worked. Either gives you the same answer. This just shows you why dividing by his salary works. We are not going to be doing a lot of algebra here. That's not the main goal right now. The main goal is really just understanding the graphs and stuff like that. But we're going to slowly see this algebra over time. We're just trying to get used to it a little bit before we have to use it for everything. R. It's HR. R. Sorry, I know it's not very neat. Okay, so you got one more question just down below on the next page. I just want you guys to do that one here. And I've chosen, first off, before you even go into that, what makes this a difficult question or a little bit of a harder question? Decimals. So think about how you're going to deal with that. You're all probably going to get different looking graphs, and that's okay. It is a growing skill. Do not expect to be like, yeah, I'm a master grapher at this point. You won't be. I'm not. I've been doing this for, oh God, like 25 years. So I'm going to give you guys like 5 minutes here. Just try and make a graph here. Think about these 4 little rules here. Just do, give it a little bit of thought before you dive deep into it. I'll come check and see how we're doing in 2 minutes.
I'll come check and see how we're doing in one more minute. Pardon?
Yeah, send to these. So tomorrow, I can. See what credit?
Yes, would you be able to like join Zoom at all?
Hey. I just have to, I just, how do I do that?
So on the LMS, like if you go to like the workplace and apprenticeship, I have the Zoom link there.
Okay, and then that's just that, so I would log in on my Carlton Trail email.